Here are solutions to homework set number 10 for ECE 341. In this homework set, we're looking at testing with normal distributions. So the first problem, we're looking at the month of January in Fargo, North Dakota. This is the average low and the standard deviation for the low for the month. With that, give me the 80% confidence interval for how cold it's going to get this coming January. So for 80% confidence interval, I want the area in the middle to be 80%. The left tail is 10%, and the right tail is 10%. And that's a mistake students oftentimes make. I want 80% confidence interval, so each tail isn't 20%, it's half of that, because I have two tails. With 10% tails, I can find the z-score. That's how far I am for the mean in terms of standard deviations, so that the tail is 10%. And that winds up being 1.28155. Get that from StatTrack. You can get that from standard normal table. A couple ways of getting that. Once I know the z-score, I take the mean plus and minus 1.28 standard deviations. So that works out to the low this coming January is somewhere between minus 34 and minus 13 degrees Fahrenheit, with a probability of 0.8. If I want to be more certain, say I want to be 99% certain, I go to a standard normal table and find out where's the tail, 0.5%. So that's 0.5, this is 99%, and here's 0.5%. That z-score is 2.57, so go left and right of the mean, 2.57 standard deviations. That gives you minus 45 to minus 2, pretty big spread. The more certain you are, the bigger the spread. If I want to be guaranteed 100% certain, it's between minus infinity and plus infinity. So 100% certainty isn't useful. You've got to give a confidence level less than 100% to get anything meaningful. And the more certain you are, the bigger the spread's going to get. Problem 2. What's the chance it's going to get colder than minus 35 this coming January? That's a single-sided test. So here's the mean. Here's minus 35 Fahrenheit. How far is minus 35 from the mean? So I want to find out what's that area. You first find the z-score. Minus 35 degrees is 1.35 standard deviations away. That's your z-score. Go to a standard normal table or a StatTrack, convert that to a probability, and it works out this is 8.7%. So there's an 8.7% chance that it's going to get colder than minus 35 this coming January. And for those of you not from North Dakota, yes, that is cold. And from StatTrack, just type in the z-score, it spits out the probability. StatTrack is actually really useful. Problem 3. What's the chance of a killing frost in June? Killing frost is when it gets below 28 Fahrenheit. So what I do is I go back to my data. I look for the low in June, somewhere up here, this data. There's the mean, there's the standard deviation. How far is 28 degrees from the mean in terms of standard deviations? That's the z-score. So here's the low in June. The mean is like minus 40.4 degrees. Standard deviation is 4.15. Here's a killing frost. What's the area of that tail? Again, to do that, I find the z-score. How far is minus 28 from the mean in terms of standard deviations? It is 2.98 standard deviations away. Go to a standard normal table, convert that to a probability. The area is 0.0014. So it could happen. The odds against it are about 700 to 1, but once every 700 years, on average, we'll have a killing frost in June. So that's testing with one population. If I have two populations, what I can do is form a new variable w that's the difference in the two. A normal distribution really only works for a single population, but I can convert 2 into 1 by taking the difference. So if I have January and February, let's call A January, B February. Let's have W be A minus B. The mean of W is the difference in the means, minus 3 degrees Fahrenheit. The variance will add. The variance is 129, square root, standard deviation is 11. So I get a normal distribution. This is for W. The mean of W is minus 3.2 degrees Fahrenheit. 0 is right here. This right here to the right of 0 is A greater than B. To the left of 0 is A less than B. What's the chance that A is bigger than B? January is warmer than February. To determine that, I want to find out the z-score. How far is 0 from the mean in terms of standard deviations? It is 2.28 standard deviations away. Go to StatTrack, convert that z-score to a probability, it's 38%. And this is where drawing it's kind of helpful. The area to the right is 38%. Area to the left is 62%. So 62% chance that January is colder than February, 38% chance February is colder than January. That's kind of what it looks like. Problem 5. I've taken 20 years, or 20 months, 20 years of data for the low in September, low in October, shuffled them. Can you unseparate them? Well, September is warmer than October, so what I'll probably do is take the warmest 10, call that September, take the coldest 10, call that October, not knowing anything better. So I've separated the data. What's the chance that I'm wrong? There's a false positive and false negative, so I treat this as a positive, this is a negative. I've got my two distributions. Here's September, here's October, and here's my threshold. The threshold is halfway between 24.5. A false positive is this area right here. It's October, and I call it September. A false negative is this area. It's September, but I called it October. To determine that, I find out the area of the tail. To do that, I find out how far is the threshold. 24.91, pick a number. How far is the threshold from the mean in terms of standard deviations? For October, it is 1 deviation away, giving you 14% chance. So this area right here is 14%. For September, the threshold is 1.17 deviations away, gives an area of 11%. So this guy right here is 11%. So at the threshold that I chose, there's 11% chance of a false negative, 14% chance of a false positive. The two overlap, so there's always going to be some chance of a mistake. That's the idea of false positives, false negatives. In this case, it really doesn't make a huge difference. It's just sorting data. Sometimes it does. Like if you're diagnosing somebody with cancer, and here you say negative, positive. False positive, you scare the bejeebers out of somebody saying they have cancer when they don't. False negative, they have cancer and you missed it. So they're both kind of bad. Problem 7. Problem 7 looks at regression analysis. Now, if you go to this spot, you've got the weather in Fargo since 1940. Let's take the month of March. This is the average temperature in March since 1940. Is there a trend? Well, to do that, I'm going to do some curve fitting. I am going to curve fit a straight line. Temperature is A times Y plus B. What line minimizes the sum squared difference between the data and that line? To do that, I set up the basis function. That's going to be year and 1. Your constants A and B will be the least squares curve fit. It's the inverse of B transpose B times times Y. In this case, the temperature in March. And I get A and B. What that tells you is that the temperature is going up by 0.05 degrees per year. And if I went back to the year 0, I'd be minus 77, which that's just an offset trying to get it to match up. So the slope is 0.05 degrees per year. In 81 years, Fargo's gotten warmer by 4.23 degrees Fahrenheit. So if you just look at Fargo data, you can tell that we are getting warmer. And finally, number 8. What's the correlation between the temperatures in February and March? So if we look at February's data, do the covariance between February and March, find the correlation coefficient between the two. February and March have a correlation of 33%. What that means that if it's a warm February, it's 33% more likely that it will also be a warm March. So it's kind of a weak correlation, but it is a positive correlation and non-zero. So that is 1 month out. If I go 5 months out, what's the correlation? March versus July. Again, find the covariance, find the correlation coefficient at 6%. So 1 month out is kind of a weak correlation. 5 months out, basically no correlation. That's one of the reasons it makes it so hard to predict the weather. If it's a warm month this month, 5 months out doesn't really tell you much. So that is homework set number 10 for ECE 341.